is that I get to network over with the people with other departments as well. It is no wonder that in the last 5 years, the major technology startups that have made
the Institute of Eminence scheme has been launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research institutions. IIT Madras is proud to have been selected as one of the select institutes of excellence. As part of our commitment to the cause of fostering world-class research, IIT Madras has set up a number of research initiatives in diverse fields of contemporary relevance. Many of these initiatives will go on to become centers of excellence within the IIT Madras system. A total of 68 research initiatives belonging to 21 identified technology clusters are presently underway. As part of these initiatives, it is proposed to host a series of webinars from each cluster to showcase the innovative research being generated to various stakeholders like researchers, industrialists, and policymakers. IIT Madras is happy to present the second webinar of this series under the cluster Circular Economy. The first webinar is on water and sustainability by Professor Liji Philip and Professor B.S. Murthy, moderated by Professor Nicola Forer. The second webinar is on low carbon clean construction technologies by Professor Manu Santanam, Professor Ravindra Gettu, Professor Benny Rappe, and Professor Ashwin Mahalingam, moderated by Professor Alexander. These webinars will give an opportunity to engage in conversation with eminent faculty from IIT Madras and other international researchers, and also to find more collaboration in those research areas. So why wait? Click the link below to be a part of this.
Good evening and a warm welcome to everyone here. I, Ujjwala Koti, working as a lead program administrator in the Office of Global Engagement, wants to thank you for joining us today for the fifth webinar in the IRIS webinar series. Today's session is on the research initiative titled Water and Sustainability, is led by Professor Liji Philip and Professor B.S. Murthy. A few words about our speakers and moderator this evening. Professor Liji Philip is Anita and K.G. Ganpati Chair Professor in the Department of Civil Engineering at the Indian Institute of Technology, Madras. She is also the Dean Planning at IIT Madras. Her broad areas of interest include environmental biotechnology and rural water supply and sanitation. She was area coordinator for waste management at the Indo-German Center for the Sustainability for 10 years. She is a fellow of Indian National Academy of Engineering and Royal Society of Chemistry, London. Professor B.S. Murthy is the Institute Chair Professor in the Department of Civil Engineering at the IIT Madras. His broad areas of interest include computational hydraulics, contaminant transport modeling, water supply, and sewerage networks. He was area coordinator for water management at the Indo-German Center for Sustainability for 10 years. Our moderator, Professor Nicola Forer, is the director of the Institute of National Resource Conservation, Department of Hydrology and Water Resources Management at the University of Kiel, Germany. Her research areas include ecohydrology, hydrological modeling, water quality, and aquatic ecosystems. She is currently the Vice President of the German Hydrological Society. She is also the area coordinator for water management at the Indo-German Center for Sustainability. I welcome you all for today's evening session, and over to you, Professor KG.
Okay, I will share my screen and get back. A very good evening to all of you, and welcome to this brief overview on the Center of Excellence on Water and Sustainability through Circular Economy Principles. I am making this presentation on behalf of the team led by Professor Liji Philip, It has a totally 9 faculty members from IIT Madras. 6 of us are from civil engineering department, and 2 from chemical engineering department, and 1 from electrical engineering department. The motivation for the center comes from the fact that water is an integral component of sustainable development goals, especially the 3 SDGs. The SDG 6, clean water and sanitation, SDG 11, sustainable cities and communities, and SDG 12, responsible consumption and production. We want to achieve these SDG goals, the sustainable development goals, through an integrated solution approach, wherein application of circular economy principles is at the core. As has been said, water systems intersect with all sections of society and industry, and opportunities exist in these interfaces to create additional value by application of circular economy principles. So the water is used majorly in 3 sectors: in the agricultural sector, domestic sector, and industry. And once it is used, the waste is generated in terms of wastewater, in terms of agricultural runoff, domestic wastewater, industrial effluent, or in terms of solid waste as agricultural residue, biosolids, and industrial sludge. And if we leave this waste as it is into the environment, we know what are the consequences. So we want to treat this waste as well as this water supply in an integrated way, in a sustainable way, by applying the 4R principles. The 4 R's are, the first one is reduce. Here we hope to increase the efficiency of agricultural water usage and reduce the leakage in the supply systems, thereby reduce the demand for fresh water. We hope to develop new technologies which can be used for treating the wastewater as well as water, so that the treated wastewater can be reused or recycled. We also hope to develop new technologies for recovery of energy and micronutrients from wastewater and the solid waste. And finally, we hope to reduce the risks in usage of these recovered materials or recovered water through the development of new sensors and application of IoT for monitoring water quality on a large scale and continuous basis. The sustainable water management, as you all know, starts with finding the sources for water. The sources water could be from rainfall, a groundwater, a desalination, or we can import water from other catchments, or we can also use treated wastewater as a resource. And once we identify the resources, then we carry out the mass balance analysis using hydrologic models, so that we know what is the available storage and if we need any new storage. And from the storage of this storage works, water is carried to different sectors for the use, like domestic sector, industrial sector, agriculture, or environment protection through water supply. Now here, the few things are very important. We need to know how to carry out this hydrologic modeling for finding out what is the availability of water now and in future, and what is the reliability of that particular water source. So hydrologic modeling becomes very important. Similarly, development of new technologies become very important. New technologies for wastewater treatment, because if you want to treat, treated wastewater is to be used as a resource. And when we supply water to the different sectors, we need to ensure the quality of water depending upon the usage. So we need to monitor water quality. For that, we need to develop new sensors. Again, we have several stakeholders for the water use and how to allocate this water so that we get a sustainable development, overall sustainable development. For that, we need to focus on our systems modeling and the water allocation models and so on. When you take the water from the sources to the users, the intervening, we have the supply system or distribution system, then how we plan, design, and operate this particular supply system in a sustainable way, or in a way that we get the very good service delivery is also of importance. After the usage of water, waste is created, generated, both liquid and solid waste. And as we have mentioned already, we are not going to treat this waste as a waste, but we are going to treat this waste as a resource. So if you want to treat this waste as a resource, then we have to focus on how we efficiently collect this particular waste so that it can be converted into a resource through application of appropriate treatment technologies. And we also have to ensure the water quality through monitoring, and for that we need the sensors. And once the water is recovered, are we going to put back this recovered water directly into our distribution system or supply system, or are we going to take it back to the source and then again bring it back to the people? That means whether we are going to go for a centralized system of management or a decentralized system of management, all those issues become of relevance. So all this research we would like to carry out in the backdrop of Chennai city as a template, where we want to prepare an integrated water management plan for that particular city. This is a template and it can be applied for others. So our research goals are the hydrologic models for water availability and allocation, materials technology for water treatment and wastewater treatment, technologies for wastewater treatment and recovery of valuable products, integrated design of water infrastructure systems, not just the design, the planning, design and operation, water quality monitoring techniques. We hope to deliver on advanced process models, novel water treatment and wastewater treatment technologies, improved methods for infrastructure design and operation, low-cost sensors for water quality assessment. I'll go into each of the sectors now. In the agricultural sector, our hope is, we plan to develop new hydrological models for forecasting water availability now and in the future, and probably improve the efficient irrigation strategies to reduce water consumption. And one thing which is close to our heart is recovery of water and nutrients from agricultural runoff, and also the treatment methods for pesticides and agricultural runoff. A lot of our water bodies are contaminated, so strategies for water body restoration is also of interest to us. Our team members in the past have contributed significantly to the development of improved hydrologic models, which can consider dynamic representation of land use change and better surface subsurface interaction. They have worked on remote sensing applications for estimation of evapotranspiration, a major component of hydrologic cycle. While doing so, we have realized that hydrology of irrigated agricultural ecosystems is quite different from other types of catchments, and not much of work has gone on in this particular field. So our focus will be on improvement of process representation in hydrologic models for irrigated ecosystems, parameterization through remote sensing, and development of decision support systems for increasing water use efficiency. When it comes to domestic water, we will be focusing on improved drinking water quality through advanced treatment and bridging the gap between the supply and demand by supplementing water through recycling and reuse, and improved monitoring of water quality and quantity, and of course, better water infrastructure planning and design and operation. For example, my colleagues have worked on the removal of emerging contaminants from water by using pulse power plasma technologies. They have developed 3 different reactor designs. They have carried out optimization of these reactors. Each of these reactors has its own advantage, and this particular technology is ready for field trials. Patents have been filed already. A few other technologies on which they have worked are sustainable systems for emerging multi-pollutants removal, UV and visible light-based photocatalysts for emerging pollutants removal, technologies for in-house water treatment systems, polymeric membranes with different nano composites for water treatment. They also have developed new absorbents for multi-antibiotic and multi-nutrient removals. So we will be continuing our research in this direction in the future at the center. As far as integrated water infrastructure networks are concerned, we have already worked a little bit on the integrated planning and design of sewerage systems and water distribution networks with recycling of treated grey water and wastewater. we will be planning to extend this work to integrate even stormwater drainage networks. So, and our colleagues have also worked on leak detection in water distribution networks, IoT-based monitoring and control, and we want to work on the development of low-cost, low-power IoT devices and smart algorithms for network management. As far as wastewater is concerned, we will be focusing on grey water for agriculture and other secondary uses. And as I said earlier, nutrient and energy recovery is of interest to us. We also, several of our colleagues are actually focusing on emerging contaminants and appropriate technologies for removal of emerging contaminants and residual pollution. Of interest to us is the risk and sustainability assessment of these technologies. For example, our colleagues have worked on ion exchange membranes for nutrient removal, and they focused on donor dialysis because it requires less energy compared to other technologies. They have also worked significantly on constructed wetland systems for wastewater treatment. We have gone from field lab scale to the field scale. Colleagues have also worked on a technology EcoFert for recovery of fertilizers and water from human waste. This is ready for pilot testing. As far as industrial waste is concerned, we will be focusing on process modification to reduce water usage and waste generation, and of course, waste minimization through reuse in downstream industries. And as I mentioned earlier, we will be focusing on toxicity and risk analysis. Our colleagues have developed a novel rotating multiple bipolar disc electrode electrochemical reactor, RBDE, for textile water treatment. This technology minimizes electrode passivation, increases mass transfer, and reduces energy consumption. One interesting aspect of this technology is electrodes are made from construction waste material, while the sludge is used as an adsorbent. They have also been working on the value addition to waste materials utilization in wastewater remediation. For example, sludge-derived biochar and agricultural waste-derived biochar, and then plastic waste-derived char, they are using as adsorbent in the downstream industry. As far as the new sensor development is concerned, this is very important for us. We have already developed a new level sensor for simultaneous measurement of level and conductivity of water. A new contact conductivity sensor for continuous monitoring of conductivity of water in pipes, not only in pipes, in tanks and lakes. They have also developed a new water quality sensor for online monitoring of recycled water, which costs less than 5,000 Indian rupees. They have also developed low-cost colorimetric sensors for the detection of nitrite ions, and then cost-effective paper-based strip sensors for detection of putrefying agents. These are all ready to get commercialized, and we are focusing on development of different sensors for different contaminants, and also an integrated sensor which can do several things simultaneously. We are very fortunate to be working with colleagues from different universities across the world, like University of California, Davis, University of Stuttgart, EWAG, Duke University, University of Exeter, Ben Gurion University of the Negev, and then Technical University of Kaiserslautern, University of Technology Sydney, Newcastle University, University of Calgary, RWTH Aachen, University of Virginia Tech, University of Birmingham, and University of Kiel, and Texas A&M University, USDA, University of Augsburg, and Macquarie University, Technical University of Kaiserslautern, and Anglia Ruskin University, and University of Connecticut. We will be continuing our collaboration with these colleagues from different universities across the world. We have also been working with different industries like Saint-Gobain, and then Torre and Tandler and ITC, the Nature Conservancy. Couple of our colleagues have their own startups like Green Environment and Waste Chakra. With this, I would stop my presentation. Thank you very much. And I would leave saying that the overarching aim of the center is to solve challenging problems in water management using the framework of a circular economy in order to achieve sustainability and water security in the backdrop of rapidly developing economies and impending climate change. That is our goal of the center. And as I mentioned, I have made this presentation on behalf of the team. All our team members are here. and they would be able to answer the questions or give clarifications. Thank you very much.
Thank you, Professor Murthy, for this excellent introduction into this really challenging new research project. I was trying to follow up the chat with, which was buzzing with questions, and I'm trying to sort them in some, well, let's at least some content blocks. So the first one is about the technology. Students were asking, what kind of software will you use for this integrated approach, and how are you going to implement your findings into practical applications?
This is, I believe, the students are asking about the integrated approach for planning and management of infrastructure. What we are doing is we are writing our own software, and we are also using the software that is already available by meshing, seamlessly, and then using an iterative coupling approach for doing the integrated planning and design. That's what we do.
Thank you. The second block is about concerns about water quality, about the pressing needs to have safe drinking water. What would you think would be the future impact of your integrated project on the availability of safe drinking water and human health and ecosystem health?
Probably Professor Liji can answer this.
Yeah. So our approach is, okay, instead of contaminating the water and treating it, okay, it will be always better to preserve the water sources. So for that one, we have to manage the wastewater and the waste properly. So our center will be concentrating on proper waste management, so that the water resources will be protected as much as possible. And see that when we do the waste treatment, okay, even the residual pollution, okay, like emerging contaminants and all are getting removed, so that when the treated water enter into the water bodies, it will not be contaminating or deteriorating the quality. So the future, okay, whatever the water source we have, it will be of good quality, so the treatment can be reduced significantly.
Thank you, Professor Liji. There's another one for you. There was the question of how to use plasma technology to clean the water from emerging contaminants.
Yeah, plasma technology is an example of an advanced oxidation technology. Okay, like any other advanced oxidation technology, here many reactive oxidation species will be generated, like hydroxyl radical, nascent oxygen, H2O2, even UV radiation, high electric field, electrons. All these things will be generated when we apply plasma, either in air or in water or in the interface. So all these oxidizing species are highly reactive. So they will be attacking the emerging contaminants and mineralizing that one.
Thank you very much, Professor Liji. There is a fourth block around water scarcity and technologies to save water, and incentives by politics to implement things like rainwater harvesting or recycling water as demanded in your project too. So what kind of incentives are available for these measures?
Yeah, I think Indu, you can add on that one. You are muted.
Yeah, the main incentives for any kind of recycling and reuse is a reduction in water bills. Although the government is charging very little, most of the time what we find as Chennai as an example, in summer, people are left to fend for themselves. The government is unable to meet the demands of the people. So they incur a lot of expenses because they are buying water for their everyday use. So the government needs to invest on more of these technologies, because we're running out of water sources. Unless reuse, recycle is implemented, we cannot meet the growing demands of the people. And this in turn is also incurring a lot of energy, because these tankers ply from one point to the other. So overall, we can reduce the water footprint and the carbon footprint, and that will be a big incentive from the government's point of view.
No, I was muted. Thank you very much, Professor Indumati, for this competent answer. We do have another block that deals with the urban drainage system, and people were wondering how you identify leaks in the system and what kind of problems they cause.
Professor Murthy?
Shankar, you want to say about when we said leak detection, we actually worked on water distribution networks, the leak detection. Shankar or Sridhar?
Yeah, primarily our focus has been on the water distribution system, not so much on the sewerage systems or drainage systems. But in this area, even because it's geographically distributed, currently there is no online sensors that we can use to monitor. We have been developing low-cost sensors, both sensors and wireless technologies that we can use for monitoring. That's one side, which will hopefully come into future. But in the meantime, we have actually developed what we call offline monitoring plans, where we actually measure a few places, the flow rates, and from there do a flow balance assessment to determine which part of the network is actually having wastage and address them suitably. So till such time as online monitoring and those technologies come into being, we can use these offline, what we call campaign modes. We can do the assessment and address the problem.
Thank you very much, Professor Shankar. There's another question grouping around sensors for water quality measurements. It's obviously lack of data will also hinder your beautiful holistic approach. So what kind of sensor techniques are you developing? Are you applying to get more reliable data in the area of water quality?
Liji,
Yeah. Yeah, so okay, we are developing all type of sensors, okay, because we have faculty from electrical engineering, chemical engineering, and civil engineering. So we have colorimetric sensors, okay, very simple, okay, a paper strip type of a sensor. Just dip it and see the color change. We will be able to measure the concentrations. For example, we have sensors for nitrite, nitrate, phosphate, and many other organic compounds. And we have optical based sensors for measuring turbidity, color, and even the water depth, okay, water quality, okay, means TDS and other parameters. And we are also looking into the absorbance-based sensors, okay, by measuring the absorbance, okay, of the samples. Okay, how can we find out what are the species present in the system? Okay, so we have a wide range of sensors which is looking into various aspects of this one. And we are concentrating on developing low-cost sensors, because if you want to deploy it in a large number, if cost comes as a, if it is high cost ones, okay, then it will be a problem. So we are concentrating on developing, okay, low-cost sensors which can be deployed in large numbers wherever needed.
Thank you, Professor Liji. We have still another block. The students were wondering if there's anything planned in terms of education and outreach to teach people how to save water and how to recycle water and to get this into their daily living.
Yeah. We have regular master's programs and diploma courses and all on that one. Apart from that one, we do have webinars on, okay, various aspects of water quality, water treatment, okay, the need for protecting our water sources, etc. So all our colleagues, okay, in our group, okay, do conduct a lot of outreach programs. We have MOOC courses, we have Vajra Gyan courses on this one, okay, by our colleagues. So yeah, so we do a lot of outreach programs in this connection. And if anybody wanted to add to this one, most welcome.
Yeah, I would like to add that we are actually taking all these things to the villages too, in the sense under the Unnat Bharat Abhiyan, as well as under the program started by IIT Madras, where we generate the corporate social responsibility funds for implementing some of these schemes in the villages for making supplying them good quality water and providing sanitation facilities. We do work in that also, and then some of our research does reach the villages and people there. This thing is a holistic approach. We do make what we call awareness programs first, teach them about importance of water quality, importance of hygiene and sanitation, and then how they should take care of their things, and then train them into the simple technologies for water quality monitoring and then reporting. So that we have done in more than about 13 villages till now in Tamil Nadu with the help of industry support. I just wanted that.
I just wanted to add one more thing, okay, because we have conducted training programs for all the panchayat presidents, secretaries, and volunteers in 2 districts of Tamil Nadu. Okay, just teaching them what is the water quality, how to measure it, what is the need, okay, how it is related to hygiene, sanitation, and health, and teach them how to monitor the water quality with very easy to use field kits and all the things. Okay, we do this type of activities extensively.
Thank you, Professor Liji. Thank you, Professor Murthy. There's another one. There is concern about the long-term usage of recycled water and the impact on human health and the enrichment of contaminants in the food chain and in the drinking water, and lastly, also in the human body. Any comments to that?
Indu, you want to answer?
Yeah. So typically, I think if you look at the new water scheme in Singapore, they've tried this treating and sending the water back into the water source. And research has proved that a parcel of water can be recycled up to 8 times before it can reach the point of not acceptance with respect to health. So at that point of time, definitely we need to have resort to some dilution methods with fresh water. That is one solution. And then we have a lot of other solutions like recovering recovering salt from reject, and also recovering water from the reject water. So we can include a lot of other advanced technologies, RO processes, capacitive deionization to further take the water from the concentrated water after these 8 times of recycling. So yeah, there is a limit. It is not going to be indefinite recycling, but then we can make it differently after the maximum recycling is possible.
Okay. Balaji, you want to add anything with respect to agriculture?
Sure. I think with respect to agriculture, I think, I mean, there are some of the research that are already ongoing with respect to using the wastewater in some of the agricultural areas. But specifically coming to irrigation water management, that's also going to be one of the major focus of our center. Because a lot of our irrigated agriculture is actually in the semi-arid regions. And I think there also the agricultural water recycling as well as, irrigation using the normal water is also going to be of prime importance. And that's going to be one of the major focus of the center as well. Yeah.
Thank you, Professor Balaji. As I have you already on the microphone, there have been 2 more questions concerning agricultural water use. One was asked if your focus is mostly on hydrological modeling of irrigated areas or if the approach is broader than that. And the other one was definitely decisively asking after the future of hydroponic systems in the context of Indian agriculture.
Okay. I think the first question regarding the focus going to be more on hydrological modeling for irrigation water management. That's going to be one of the focus, but that's not going to be the only focus of this particular center. So if you had listened to Professor Murthy, so one of the major objective as part of this particular center is also to establish a hydrologic observatory. So this observatory, we are thinking in 2 ways. There is going to be one observatory specifically located in an irrigation dominated ecosystem. Too many observatories, in this particular regard. There is also going to be one more, line of thought where we are going to establish this in a semi-arid region, which is dominated by some of the invasive species. So, what is going to be the impact of some of these invasive species on the water bodies, on the irrigation water sources, on probably the local food security, water security, energy security. So there are these are going to be two line of research that we are going to open up, where we are going to take up a lot of primary observations from experimental plots. So that's going to be part and parcel of this particular research, where we try to develop a lot of process understanding in terms of soil, vegetation, atmosphere, coupling, and how they interact with one another. So it's going to be a lot more bigger scope than focusing only on the irrigated agriculture. And with respect to hydroponics, I don't have a good idea immediately to start with. I have not worked in hydroponics quite a bit to comment, but I would say in hydroponics is one of the things that has come up quite a bit now in terms of the urban agriculture context. That's right now we are not thinking about it within the scope of this particular project, but that's something for us to think about as well in future as we go about.
Thank you very much, Professor Balaji. There's another question from the students, how to involve the private sector or entrepreneurs in these initiatives. So once you have established your methodology, how can the private sector come in to support this initiative?
Professor Liji?
Yeah, see, what are the technologies we are developing and all, okay, as we have already mentioned, we have startups, companies are there, so the technologies can be deployed by these companies. Or another thing is, when we talk about what wastewater treatment systems and all, so we consider wastewater treatment plant as a resource point. So whatever the treated water, they can buy it and sell it. Okay, and that way the private agencies, the private sector can get involved in this type of aspects. Yeah, Murthy, you want to add anything more?
No, I think that's...
Can I add one more?
Yeah.
Point? I think treatment technologies for industrial wastewater effluent is something which we have been focusing. Treatment and reuse within the industry. So we could partner as an R&D organization for the industry to solve their industry specific problem.
Just to add, there is another route also we are using for involving private industries. There is this big CSR initiative where the government forces the private industries to invest a certain percentage of their money in social service activities, and many of them have come forward to take our technologies to at least the rural village areas and so on. And that's another route that we have been attracting them to deploy our technology. We have currently some field projects going on, which are supported by private industries.
I think if I may, Murthy, can I just go ahead?
Yeah, I would like to add that, the model of 2+2 Indo-German Science and Technology Center, IGSTC projects, the 2+2 model is already there, and we can work. And several of us have been involved in that, where academic institutions and the industry partners from two different countries can come together and then work on research projects which are of relevance to industry. So industry can get involved in our center too.
Okay.
Yeah, just to add a couple of points to what has been already stated. There is always a competition for the scarce resource like water. When you look at agriculture is one of the biggest consumer of water. So I think this is where the industry can also play a role, where both agriculture as well as industry can do a win-win. There are a lot of water conservation practices, and there are a lot of methods that we could probably work with the industries, and then that could be developed in collaboration with the industries, that could be used by the farmers. So the farmers can eventually save the water. That's a water that can be released for the industry as well as the other users. So there is a lot of advantage by the industry can actually play a very constructive role in this entire exercise.
Thank you, Professor Balaji. We have one more overarching question. That is the link between water resources management and circular economy. And the question is, should we not include also the energy sector? And how does the whole thing work in the light of climate change?
Liji, you want to take this question?
I think Balaji will be better.
Okay. Okay.
Okay. And I think when we look at agriculture, when we look at water, I don't think that we can de-link energy any longer. It can be in very many different ways in terms of the inputs that go into the agriculture, the inputs, the energy inputs that go in terms of recovering the water from the waste or from whatever the resources that are there. So I think certainly, we cannot de-link energy from in many of these things. And I think that's where, some of the project topics that we have looked at, certainly we are looking at in terms of waste recovery, but in terms of energy, that's something that right now we are not directly working in terms of the energy aspects of or the energy recovery or energy saving part of that we are not directly working on, but definitely some of the sensors and the other things that we are anyways developing as part of this whole system. I think it will go towards energy, savings as well. It will go a very long way towards energy saving as well. Now, bringing in the aspects of climate change, of course, that's going to be a much more larger umbrella under which many of this activity that we are going to do, be it the waste recovery, be it water conservation, be it food security. I think many of these things are going to come under this larger umbrella of the climate change.
I would just add one sentence to that. When we talk about integrated planning and design of water infrastructure, definitely it's not just the capital investment for pipes and then things, but then the energy part of it. I mean, energy savings and operational requirements and pumping, and then the energy cost is integral part of that particular planning and design. So energy is always linked and it's there. Thank you.
Thank you, Professor Murthy. Thank you, Professor Balaji. We have one more question to the circular economy topic. What about nutrient recovery from the wastewater and for fertilizer purposes, for example, or heavy metal recovery for any industrial use?
Indu, you want to start with your system?
Yeah. So already in IIT Madras, we have developed a system where we can recover valuable fertilizers, including ammonia fertilizer and struvite, which is a phosphorus and ammonia fertilizer, from human urine. We have a working prototype in our building where all the urinals are collected, the urine from all the urinals are collected, and we are scaling it up with the help of a funding we got from an imprint project. So apart from that, we are also having a biogas unit, a prototype, and a working unit in IIT Madras, where waste and wastewater can be used to recover methane as an energy source. So we are planning to expand this to the solid waste also and come up with technologies which can make this a very robust technology. Right now, sourcing the waste to the large biogas plants is an issue. So we are looking at decentralized units for both the fertilizer recovery and energy.
Okay. Yeah, I would like to add to that one. Okay, so if the concentrations are very low, okay, for example, secondary treated wastewater, still you will be having nitrate, phosphate, etc. So we are also using ion exchange membranes. Okay, adopting Donan dialysis technology. So there we can concentrate these ions, okay, nitrate, phosphate, and all, and recover. And your treated water will be free of any of this residual pollution. So we have a pilot scale system. Okay, we are collaborating with Israel. Okay, with this technology.
Thank you, Professor thank you, Professor Indu and Professor Liji for the response. Professor Murthy, I wanted to ask, we are running a bit out of our time limits. Are we still fine to take questions, or what is the order?
Maybe we can just take one more.
One more, yeah.
And then
okay.
we'll stop.
Yeah, there was a question, how compared to the global capabilities is the circular chemistry in India? How do you how high is the recycling rate or the regaining rate of valuable resources from waste and wastewater compared to the rest of the world?
I think I can start answering this one. Compared to other countries, India was practicing circular economy knowingly or unknowingly. For example, our rat pickers. So they are recycling all the things earlier. And if you see earlier agricultural practices, they used to use wastewater for agricultural purposes and all. Yes, okay, if it is not treated properly, it leads to problem. But people were using it for agriculture purpose. Even now, okay, they are using this type of wastewater, grey water, etc. for treatment agriculture purposes. And you know that always, okay, if you have a scarcity, people will be going for recycling. So the city like Chennai, we have lot of water scarcity. So naturally, many of the industries are recycling their wastewater for the processes. Not lucky, everybody.
Can I share my screen now to play the video? Or...
Hey, good luck, everybody.
Can I share my screen now to play the video?
I'm also the CEO and co-founder of the ePlane company.
I've chosen this institute because it is one of the top leading institutions in India.
Academics is something which is the most important thing at IIT Madras. One of the most prominent sections of my institute life is doing courses. I have done courses right from sociology to history to politics and as well as in finance.
Whatever you study here, you feel there is a lot to learn in that field and there is a lot which can come out of that field.
As a student in IIT Madras, I was given the opportunity to consult with industries as well as do research work.
We also want to then start working on electric air taxis in about 1 or 2 years' time.
Here in IIT, the best thing is you can actually know whether you are passionate about this or not because you'll have the time and also opportunity to explore each and everything.
Despite being a business student over here in IIT Madras, the uniqueness over other B schools in India is that I get to network over with the people with other departments as well. It is no wonder that in the last 5 years, the major technology startups that have made headlines in India are from